Spatial computing is a revolutionary paradigm that seamlessly merges the digital and physical worlds into one cohesive environment. It allows computers to sense, interpret, and respond to our real-world surroundings, including our bodies, eyes, and hands. This means digital objects and information can naturally coexist and interact within our physical space, adapting to us rather than us adapting to screens. Traditional computing has always relied on flat interfaces, separating us from digital content. Spatial computing dissolves this boundary, integrating digital information directly into the user's immediate environment. For instance, a headset could track a person's eyes and hands, placing virtual objects that appear fixed to their desk or room. Spatial computing is not a single technology, but a collection of interconnected systems working in harmony. Key components include sensors and tracking, utilizing depth cameras, LiDAR, and motion sensors to capture object positions and user movements. Computer vision and mapping algorithms then build detailed 3D representations of the surroundings. Natural interaction allows users to engage through gestures, voice, and eye tracking, moving beyond traditional input devices. Augmented and virtual layers, through AR and VR, enable digital overlays that interact with real-world environments. AI and machine learning algorithms analyze spatial data, interpret user interactions, and enhance the overall user experience. The Internet of Things, a network of physical devices, uses spatial data to understand environments and enhance human experiences. The term gained mainstream recognition with devices like the Apple Vision Pro, described as a spatial computer. This marked an evolution from mobile computing to an era where devices understand and interact with our entire environment. Spatial computing operates through a multi-step process, beginning with data acquisition from various sensors. Next, AI and machine learning algorithms analyze this collected data to interpret spatial context and user interactions. Finally, the system uses this interpreted data to enable natural interactions and respond to user commands, blending physical and digital worlds. Spatial computing is already transforming many industries, merging digital information with real-world environments. In manufacturing, technicians wearing AR glasses can view real-time data about machinery, optimizing every step of the process. For education, students explore complex 3D models and historical sites through immersive VR classrooms, making learning active and engaging. In retail, consumers visualize furniture in their homes before buying using AR apps, enhancing the shopping experience. Healthcare benefits as surgeons use AR to overlay critical imaging data during procedures, enhancing precision and improving outcomes. Gaming and entertainment also thrive, with AR games blending digital elements with the physical world for interactive experiences. Smart buildings utilize spatial computing to optimize and automate human processes, adjusting lighting and temperature to save energy. Automotive applications include self-driving cars operating in the physical world, responding to outside stimuli using spatial computing. This new frontier also redefines design, as designers sculpt interactive 3D environments where the body itself becomes part of the interface. Despite its promise, spatial computing faces challenges, including current devices being bulky and expensive. Designing intuitive spatial interfaces is still a developing field, requiring continuous innovation. The always-on sensors raise serious privacy concerns, demanding robust data protection measures. Addressing skill gaps in AR, VR, and MR expertise is essential for broader adoption and growth. Why does spatial computing matter? It represents the next stage in our relationship with technology. It brings digital information into our physical world, making it contextually aware and more human. Instead of bending to the limits of screens, we can engage naturally with technology. Spatial computing is the leap beyond mobile computing, where technology no longer fits in our pockets, but surrounds us. It responds to us and enhances every dimension of our physical world, revolutionizing industries and user experiences. As technology continues to advance, spatial computing will shape the future of digital interactions.